Jai Hind. Today we will continue the chapter Electromagnetic Waves. The topic is electromagnetic spectrum. It is the orderly distribution of the electromagnetic waves in accordance with their wavelength or frequency into distinct groups having widely differing properties. Simply, electromagnetic spectrum is the classification of electromagnetic waves with their wavelength or frequency. There are different types of electromagnetic waves. Here, the electromagnetic waves are arranged in the decreasing order of wavelength. They are radio waves, microwaves, infrared waves, visible light, ultraviolet light, X-rays and gamma rays. To remember all these waves, you just remember the initials of these waves. That is R, M, I, V, U, X and G. Also, you can use some codes to remember these EM waves in the decreasing order of wavelength. One such code is given here, that is red man in violet uniform with X gun. Red R represents radio waves, man M represents microwaves, in I represents infrared waves, violet V represents visible light, uniform U represents ultraviolet light, X X-rays, gun G represents gamma rays. There is a relation between wavelength, frequency, velocity and energy of the EM waves. Velocity of the electromagnetic wave is equal to velocity of light. So, the relation between velocity, frequency and lambda is C equal to nu lambda. It implies lambda equal to C by nu. The relation between energy and the frequency is E equal to h nu, where nu equal to Z by lambda. Therefore, E equal to hc by lambda. From these two relations, we can write E is proportional to nu and E is proportional to 1 by lambda. From this equation, E is proportional to nu. When the frequency of the electromagnetic wave increases, energy of the electromagnetic wave also increases. So, gamma rays has maximum frequency, so it has the maximum energy, and radio waves has minimum frequency, so it has the minimum energy, and the relation between energy and the wavelength is E is proportional to 1 by lambda. So, gamma rays has minimum wavelength, so it has the maximum energy because it is inversely proportional to each other, and the radio waves has maximum wavelength, it has the minimum energy. So, thank you. I hope you understand types of waves, wavelength, frequency, velocity and energy. Now you are going to study about magnitude of wavelength, frequency, source and uses. Waves are classified according to wavelength and frequency. First wave is radio waves. Its wavelength is 600 meter to 0.1 meter and frequency 500 kHz to 1000 MHz. Next, source of radio waves, from where it is generated. You studied any EM waves get generated from accelerated charges. So, radio waves are produced by the accelerated motion of charges in conducting wires. Radio waves are used in radio astronomy, in radio and television communication systems and voice communication over mobile phones. They are transmitted easily through air. They do not cause damage if absorbed by the human body, and they can be reflected to change their direction. These properties make them ideal for communications. Next wave is microwaves. Wavelength 0.3 meter to 10 raised to minus 3 meter. Frequency range 10 raised to 9 Hz to 10 raised to 12 Hz. Microwaves are produced by oscillating currents in special vacuum tubes like klystrons, magnetrons and gun diodes. Detail you will study in higher classes. Used in long-distance communication systems through geostationary satellites. Used in microwave ovens. High-frequency microwaves are easily absorbed by molecules in food. So, the internal energy of the molecules increases, which causes heating. Used in radar systems for aircraft navigation. Next, infrared waves. They are called heat waves or thermal radiation because they produce heating effect. Its wavelength 5 into 10 raised to minus 3 meter to 10 raised to minus 6 meter, frequency 10 raised to 11 hertz to 5 into 10 raised to 14 hertz. Hot bodies and molecules are the sources of infrared waves. Depending upon the temperature of objects, every object generates infrared waves. Infrared waves are used in physiotherapy and also used to capture photography of objects in darkness. Infrared waves are used in the treatment of muscular complaints. Infrared photographs are used in weather forecasting. These radiations are less scattered than visible light by atmospheric particles, so they are not absorbed by air, thick fog, mist, etc., and used to take photograph of long distance objects. These radiations are used to study the molecular structure. Used in greenhouses to keep the plants warm. Due to radiations from the sun, objects on earth becomes hot. These hot objects emit infrared waves. These infrared waves are trapped by greenhouse gases like carbon dioxide, methane, water vapor. As a result, temperature of earth increases and it is suitable for the survival of living organisms. Used in reading the secret writings on the ancient walls. Thank you.